All right, let's let the circle go. Aufbau diagrams are another way of showing where the electrons are, and it utilizes the SPDF notation, but it describes the process of building up. In other words, the electrons are going to fill in the lowest energy levels first. We also know, based on the magnetism of different atoms, that Hund's rule is an important rule. Every suborbital gets one electron before any pairing occurs. And then the Pauli exclusion principle describes that electrons in the same suborbital must be opposite in spin. So what is meant by a suborbital? Well, let's look at this. The s orbital has a spherical shape, and there's only one of those, so the s orbital is the only kind of s orbital there will ever be. But a p orbital has this petal and this petal for the up and down orientation. We call this pz because that is the z-axis. But then there's also the ones that can lie sideways on the px axis, and then there's also the ones along the the y-axis. So that would be the ones that were coming out of the plane of the screen and back into the plane behind the plane of the screen. So we have the ability to describe 3 suborbitals for the p shape. So the orbital is p, the suborbitals would be pz, px, or py, depending on what orientation it is in 3-dimensional space. And then, of course, the suborbitals for the D shell, we have 5 different shapes. And in the F shell, there are 7 different shapes. And if you go back to the screen, you can rewind to see what those 5 different shapes look like. I will sketch one of them. There's one where here's your X, Y, and Z axis, and then the lobes lie in the quadrants rather than along the axes. That would be one of your D shapes. As far as the rest, I'm not going to draw them, and forget about trying to draw F shapes because I'm just not that skilled. These are our rules for Aufbau diagrams. We're going to be building up. That's a German word. It means to build up. And we're going to use arrows to show each electron. Electrons can be in the same orbital if one is spinning up and the other one is spinning down. That's how it works. And again, we're going to go from left to right and from top to bottom on the periodic table so we can fill in our diagram. In the Aufbau diagram, one of the most critical things is that the S is at the bottom and the 1 is at the bottom. And notice how all the S's are lined up. Every orbital lines up in a vertical column, and then every p orbital is lined up in the next column to the right, because this way all of our 2's are on the diagonal with one another, and all the 3's lie along a diagonal, and then all the 4's, if I could draw straight lines, and the 5's and 6's and so on. So they're all on the same diagonal line, and we can trace the filling of the electrons from the lowest energy levels to the highest. So I think we should do one. Yes? How about we do something that's simple first, and then we'll do one that's hard. So first let's try carbon. So carbon is number 6 on the periodic table. That means it has 6 protons and 6 electrons. We're going to start filling in from top to bottom and left to right, or in this case, on an Aufbau diagram, bottom to top. We build up from the lowest energy level to the highest. So here's my first electron goes in 1s, and my second electron also goes in 1s because I can fit a maximum of 2 electrons in that spherical shape. Once that's full, I have to go on to the next energy level. So take a look at the periodic table. Notice that on the periodic table, how many boxes are in the first row? 2, because it can hold a maximum of 2 electrons. All right, well, what are we going to do in the second row? Here's our second row. Lithium, beryllium, and so on. In this second row, we can hold a maximum of 8 electrons because it takes 8 steps to get all the way across. But we're not going all the way. We're just going to carbon. That's going to be 1, 2, 3, 4 steps across. So let's put that in our Aufbau diagram. We're going to go 4 more steps. We need 4 electrons. I can put 2 in my S, and that's it. I still need 2 more, so I have to go to my next level. In the P orbital, I'm going to put 1 here. My next one goes in the next level over. Remember, we have the X and the Y and the Z orientations to put these in. Every suborbital gets to have 1 electron before we start pairing them up. So I'm not going to put my next electron here. That's not where it goes. It goes in my next suborbital. And so what we accomplish here is that we maximize the spin number so that my next electron is going to go in here, so I have the most angular momentum spinning all in the same direction before I start pairing things up. That's just how electrons fill in the orbitals. So for carbon, I wouldn't have this one here. I would just have 1, 2, 3, 4, 5, 6 electrons means I need 6 arrows. And you can see then what's carbon going to have to do to react with something else. We're going to have to find something where I can get another electron here, and then 1 here, and 1 here. So don't I need 4 electrons? Oh yeah, and another one goes there, because carbon has 4 places on which it will form a bond. It has 4 electrons in its valence shell, 2 in the S and 2 in the P, and it's going to react so that it can have a partner for each of those electrons. So carbon tends to share its electrons when it reacts with other atoms in such a way that it can fill in those empty spaces in its Aufbau diagram. So the Aufbau diagram helps us to understand how it reacts with other things. You ready to do something a little bit harder? Let's go a little higher in the periodic table. Come back to the periodic table, and let's do this time, how about potassium? Because that will also be very telling in understanding how potassium reacts. Here's potassium on the left side. It's in the 4th row down, and so I know I'm going to get to the 4th energy level on my Aufbau diagram. Notice the number of electrons is 19, so I'm going to go from top to bottom, left to right on the periodic table as I fill in my Aufbau diagram from the bottom to the top with arrows. So let's get back to the Aufbau diagram. So let's just start filling in my arrows, pairing up as we go. So there's 4, 5, 6, 7, 8, 9. Got to go up, down, up, down. Each level gets an electron until I get to the 4th row, and then I want to be careful. Since the 4th row is where potassium is, I've got to make sure I do this right. So let me bring up that periodic table again. Here's potassium. It is the first element in the 4th row. That means I get 1 electron, right? We are counting across from left to right, and it's the first one there. That means I only get 1 electron. So back to my Aufbau diagram. In my 4s, I get to put 1 electron. So now let's talk about how potassium reacts with other elements. Potassium, just like everything else, wants to get to a stable configuration where its outside energy level is completely full. What we see is its outside energy level, the 4th level, is mostly empty. There's only 1 electron there. Well, tell me, if you are the only guy at a party or the only girl at a party, are you likely to stay, or are you going to leave and go find another party? Well, this electron is out of here. That electron tends to leave and go find another place to live, because then that makes the entire configuration for potassium much more like the configuration of a noble gas. It's more stable because every little spot has got an electron, and the electrons all have a partner. So that's why potassium tends to lose an electron and form a positive ion. Once it gets rid of that one electron, it's going to obtain a positive charge, and it's much more stable that way. So that's how potassium reacts. Now let's do a really big one. Something from the D block. Let's do something normal, and then we'll do a weirdo. Let's look at manganese, because manganese is kind of a normal type of atom. It's in the 4th row, so just like potassium, we're going to be filling in up to the level 4, and then we're going to go into the D block. Remember, D is going to be N minus 1, so not 4D, but 3D. And that's where we're going to land. Let's count across now. In the 4th level, 1 and 2, so we'll put 2 electrons in the 4s. This is my S block. Then in my D block, let's count across. 1, 2, 3, 4, 5. So I'm going to put 5 arrows in my D block. Oh, this is going to be an interesting one. Back to the Aufbau diagram. So let's start putting our arrows in. So we just fill in up arrows and down arrows until we get all the way to where manganese lives, which is in the 3D. So here's our target, 3D. So keep putting your arrows in till we get there. Oops, got to go up and down in the same little space. If my arrows start looking funky, don't worry, that's kind of normal. All right, now 5 arrows. 1, 2, 3, 4, and I'm missing a space. 5. That's not good. The D block needs to have 5 spaces because there's 5 suborbitals. So I'll have to go back and fix my Aufbau diagram spaces. So manganese fills in 1 electron in each of these 5. So a half-filled orbital, where we have at least 1 electron in each suborbital, is a fairly stable configuration. It's not the best, but it's better than having this guy missing, right? So the half-filled orbital is going to be more stable and less reactive chemically speaking. So that's what we find for manganese, and everybody in the same column as manganese, that it's slightly less reactive than its neighbors on the periodic table because it does have 1 electron at least in each of the suborbitals for each different shape that a d orbital could be. That's how we do manganese. Now let's do something with f orbitals. Let me count my spaces here. 1, 2, 3, 4, 5. That's not going to do. I need 7 spaces. So if you would, at home, kindly fix your f orbitals in that Aufbau diagram. I'm going to try and have these fixed for you before you have to build these, but go ahead and fix them now in your packet. And let's go back to the periodic table. Find something in the F block. Remember, the F block is the one way down at the bottom of your periodic table. And, what should we do? Dysprosium, holmium, erbium. Let's do americium. Down on the bottom. Long live americium. Right down here. 95 electrons. Well, I think it's probably time, if we're going to put 95 little arrows on our Aufbau diagram, then I'm going to have to show you the shortcut. We're going all the way down to row 7 here. So I'm filling in electrons every place through 7s, and then remember, F block is going to be 2 levels lower, so it's the 5F that fills in after the 7S fills in. So we're going in order on the periodic table, top to bottom, left to right, until we get all the way down here to americium, which we can't really get much bigger than that. So down we go to our Aufbau diagram. 95 electrons, here we come, americium number 95. So here's my shortcut. Draw half of an arrow, 1 up, 1 down. Good enough, because everyone in the world is going to know you mean a spin-paired set of electrons in each orbital. This is going to save us a lot of time instead of drawing all those little tiny arrowheads. Oops, I got to fill in 3D before I fill in my 4P. Sorry. That's important. We cannot go into the 4P until the 3D is full. And then 4D comes after 5S. That's why, vertically speaking, the 4D is slightly lower than the 5P, because we're going from bottom up, right? Aufbau means to build up. All right, we're at 6S now. Then we go to 4F. So from 6S, then to 4F, why did that happen? Let me show you on the periodic table where we go. Give it a chance to get there. All right, here's where the 6S level is, right here. So we have 55, 56. Where's our 57? Way down here in the F block. Filling in after the 6S, we go straight into 4F. All right, so after 6S, we go to 4F. Just fill it in because Americium is in 5F, so we've got to fill in all of these. After 4F fills up, then we're in the 5D. What comes after the F electrons? We're going to have to look at the periodic table because I really want you to see where I am and what I'm doing here. All right, look what we've got. Here's where the 6th row is going crazy. So we have 6S, then 4F, then after 4F is at the end at number 70, so we have to do 71 comes next, right? 71 is in the D block. And so that's why we're back in the D block. The energy level for the D block is 1 less than the S, not 2 less. So we had 4F, and then we go to 5D because we're only now 1 less than the S block. Go back to Aufbau, and we'll finish up our arrows. So we fill in the 5D, then we go to the 6P. You're going to have your periodic tables out in my classroom, folding and unfolding, so that we can show where we're going. Finally, we're in the 7th row, all the way at the end. And then Americium, after filling in electrons to 7S, is going to do how many for the 5F? We've got to count across from left to right in the F block till we land on Americium. So here we go. Let's do some counting. Get my color out that we can read. 1, 2, 3, 4, 5, 6, 7 will land us right on Americium. So we've got to put 7 electrons into that F orbital. So here we go. Spin up, 2, 3, 4, 5, and I need 7 lines. What happened to my lines? Put these in there. Okay, then let's see, 1, 2, 3, 4, 5, 6, 7, and that's it. Americium also has, like manganese, the half-filled orbitals. They would be completely filled if I could go through and put the down-spinning electrons in each of the suborbitals. Half-filled, though, is more stable than partially filled or just 1 or 2, right? Completely filled would be best. Half-filled is more stable than partially filled, but that's where we stop for Americium. Now we had better have 95 arrows in all of this diagram or we've done something wrong. And we didn't. We did it right because I went back and fixed any of our mistakes. Did we get enough in the D? No, I didn't, because those were 1 short. I'm going to have to fix my Aufbau skeletons. So you can do any element in an Aufbau diagram. You've just got to take your time, go from left to right, top to bottom, and then start building up.